How's it going? So I'm going to talk about modern standby, my work I've been doing with on modern standby on FreeBSD. So actually, I took a 15-minute talk because I didn't think I'd have too much to talk about, but I mean it kind of ballooned. So I might gloss over a few things, and if I speak a bit too quickly, as I tend to do, please yell, or maybe don't yell, just make me know. Anyway, so a bit about me. My two interests, I guess, are OSs and graphics programming. I'm sponsored by the FreeBSD Foundation to work on S0ix and modern standby, and I work at a company called Renewable, which does energy storage stuff in Belgium. And yeah, I spend most of my time in a train. Actually, I think my second true passion in life, apart from my dog, is trains. I'm really a huge nerd. Anyway, so a bit of background about what the issue is. So in the past, computers had something called S3. And in modern laptops, just to ease BIOS development, this kind of got removed in favor of something called S0ix. And FreeBSD doesn't support S0ix. Therefore, FreeBSD can't sleep on modern laptops. And therefore, well, FreeBSD can't sleep on modern laptops. So a bit of previous work. Ben Wodowski from Intel in 2018 made these two revisions. Things have kind of changed since then, so there was quite a bit of stuff to do to pick up on. I'm going to talk about that. So, what is ACPI S3 exactly? So ACPI defines a bunch of like global states. You've got S0 for a system that's fully awake and running, S5 when it's off, and S3 was suspending to RAM. So RAM stays on, all devices turn off, and the CPU is turned off. And then when you restart, then I mean your RAM's already there. You don't have to do all that much. And so it's a pretty heavy-handed approach. You're just asking firmware to go to sleep, and then firmware just does it, and you don't really have too much control over that. And one of the implications of that is that entering and exiting sleep with S3 is kind of slow. And ideally, you want it to be as quick as possible to just be able to, like, you know, close your laptop, it go to sleep, and open it, and it be ready to go. So as opposed to S3, S0ix, your system is always staying in S0. And your firmware decides when to enter S0ix, one of the S0ix states, and turn off the CPU, just depending on some power constraints. So yeah, and so the end goal is S0i3. That's the thing where your CPU is completely off, and that's the thing that saves the most power. So just a bit of terminology. When I speak of a shallower power state, that means that it's closer to being on. So that's a smaller number. So S0 is on. That's a smaller number. It's shallower. It's closer to being on. Deeper is the opposite, and yeah, LPI just stands for low power idle. So, yes, a bit of a crash course on ACPI for a bit of context. What ACPI is basically your firmware exposes a bunch of information about the hardware in something called AML, which is kind of like yeah, bytecode, and it also contains like a few methods for your OS to tell devices what to do. And so here's an example of some decompiled AML. This is ASL for the lid device. So here we're defining, the firmware is defining, oh, here's this lid. This is its ID, and this is what your kernel uses to know that this is a lid device. And then here's an example of a method which will return the state of the lid. And so in C, how would you use that? Well, you get the integer at the lid object, and here saying if there was a failure, then we default to saying that the lid is open. And if there was no failure, then if the lid status is different to 0, then it means, okay, if it's not 0, then this is 1, and if it is 0, then it's anyway, whatever. Okay, SPMC, System Power Management Controller. So this is a thing that that defines what are called DSMs. So DSMs are like these kind of multiplexed functions where it's like a specific ACPI function where your vendor can define whatever they want on it. So generally the first argument is the UUID that your vendor exposes, and from that you know that, oh, it's this UUID, so I can use these specific vendor-specific functions. And so there are 3, or I guess 5 important ones for the SPMC. The first one is get device constraints. So here you're asking the SPMC, oh, give me a list of the states that I need to put my devices in to be able to enter a low power idle state. And then you've got display off and entry and exit and display on, which are just telling firmware, oh, we're going into a sleep state, or we want to go into a sleep state, or we're exiting it. And there's a few vendor-specific complications which I'll kind of gloss over. Okay, next thing I want to talk about are D states. These are those device states that you need to put your stuff in. So D0 is on, D3 is off. I'm not going to go into the difference between D3 cold and D3 hot, but there's some complications with that, but that's not too important. And which D state you're in, you can get that by through power resources. So here's an example of the NVMe device where you have these power resource objects that are defined, and a power resource object is just a list of power resources which this specific state depends on. So you start, if for example you wanted to, know, okay, say P0NV is on as a power state, then you know that you're in PR0 because this is the shallowest state that depends on it. If this was off, then you'd be in D3 cold because you're at the lowest power state. It's roughly explained here, but again, I'm not going to go too much into this in the interest of time. So, suspend-to-idle. What is suspend-to-idle exactly? So, this is kind of distinct to S0ix states. Suspend-to-idle is basically just telling your CPU, stop working, just idle. And when your CPU is idle is when your firmware can decide to go into a deeper sleep state. And you do this with the x86 mwait instruction, which is usually used in conjunction with monitor, but you can give it a hint to say instead of breaking out of this state when a specific piece of RAM or a piece of memory is modified, we break out when we get an interrupt. And then you can also define in EAX the C state that we want the CPU to idle to. So yeah, since we wake from idle on interrupts, we kind of want to disable all the interrupts that we have on our system, except for the ACPI S3 interrupts, which is interrupt 9 usually. And that interrupt is basically used for wake events. So maybe I press my power button, then I want my computer to wake. Maybe I open the lid. That would be that kind of stuff. The only issue is that the firmware talks a lot, and we don't want to stop breakouts of idle every single time the firmware has something to say. So normally you do this with, you can choose if a device interrupts or sends these events with DSW. But the issue is that some pretty important wake devices are kind of hidden away behind the same GPE as, or the same event number as other very talkative things. So for example, here you can see on the embedded controller device, you have your lid notifications and your battery notifications. The battery in normal running, at least on my laptop, sends a GPE every second. So this would interrupt the CPU every second. And you can't mask that out, because if you mask that out, then you wouldn't be able to detect when the lid opens to break out of idle, which is obviously a bit of a problem. So the solution, I don't know, it's not super clear. Telling the SPMC to enter and exit sleep solves sort of the issue. So my battery, instead of reporting its state every second, it reports it every minute. Yeah, the best effort solution, and this is what Linux does too, is to idle loop. So if we break out of idle, we check what was the last interrupt, what was the reason we broke out of idle the last time, and if it wasn't what we consider a wake device, then we go immediately back to sleep. So not spend too much time, And on AMD, the SMU, System Management Unit, needs to be hinted that we're entering and exiting sleep, and that might also tell the CPU to, or I guess the firmware to shut up. But it's that's not working fully yet. Actually, I found this kind of funny in all these trying to get it to stay in idle problems. Yesterday, I was at a bar with Alex and Alex, two Alexes, and I saw this sticker. Yeah, say idle fucking sucks. I thought that was funny. Anyway, debugging. On Intel, you have something called the low power idle state table, which basically has these residency counters. And residency counters are just registers that count up for how long it's been in a specific state, so you know if it's actually gone into that state. Unfortunately, and its replacement is LPI and ACPI, but unfortunately, it seems like most platforms don't actually expose residency counters through that, so it's kind of useless. But on AMD, you have something called the SMU, which is a small part of the chip. And it runs this power management firmware. And you can send commands to it to ask it, oh, have I gone into S0ix or not? So that's that. So yeah, for now, S0ix, we can't really enter it. There's a bit of a prerequisite for this, which is writing a USB 4 connection manager, which I'm looking into, but we'll see when that gets done. Either way, there's still quite a bit more work needed. So, demo. This might break, this might not break, so I'm just going to go over these few other slides. So, future, actually get in S0ix. I want to be able to give the users to define more complex wake rules. So, for example, always try to idle the CPU when the lid is closed. Hibernate. I'm not working on this, but this is just suspending, putting the memory to disk, so you're saving even more power. And idleness of termination, I'm not going to go into this. So there's a public issue tracker for all these like laptop-related projects. You can find this, and please test, see if it works. Here's my contact, and I'm going to try to demo. OK, so I should have, if I go back here and here, let's see. I can't actually see what I'm doing on this. Let's see. sysctl. OK, so here I've set the power button state to go into S2-idle when I press it. And hopefully, if I press this, it will go to sleep. Now, you're not going to see anything change, but trust me, it's gone to sleep. And now I can like press the keyboard to break it out of sleep. And hopefully, I've never actually tested this with HDMI. It might just like, it seems to kind of work. I don't know. It went better than I expected. Anyway, that's that.